great space to have an event, so thank you. I also have been informed that Comcast is hiring for their data science team, so if anybody is interested, please stop by and talk with Brian, and also on our site we'll have Comcast post some of those job openings. For the Data Science Association members, we have an event coming up in Boulder, at Galvanize in Boulder on March 10th. If any of you are interested in natural language processing and graph databases, there's going to be a wonderful speaker there. I also am curious, I was just talking with Gary, one of my colleagues, about the FBI versus Apple case. How many people have heard about the privacy issues in FBI and Apple? Okay, I just want to show of hands. I promise you I won't remember. I'm just curious, the government's basic claim is that they can force Apple to write new code for a back door, for not only the FBI to get in, but it's a slippery slope. Then any terrorist or criminal organization or any Tom, Dick, and Harry could get in through that back door. So FBI's position is that they can force Apple to do that. How many people support the FBI? Don't be shy, it's okay. Okay, and Apple's position is, government, FBI, we want you to be able to access the phone. This is a mass murderer, but you can't force us to create a back door into the phone that any other organization, a criminal, a terrorist, anybody would be able to use to get in. And how many people side with that position, with Apple? Okay, so that confirms. I thought most of you would be on the side of Apple and privacy, and I am too, and I think that this is a really important issue. The case was won in New York, and the judge wrote a really fantastic decision, basically saying that, recognizing that people, us as individuals, have human privacy rights for our data, and Apple should be allowed to create that, and the government basically doesn't have the power to force Apple to create a backdoor way in. Now, we still have the California case, and again, I would like the FBI to be able to access that phone, but I'm hoping that we get another good legal decision that protects our privacy rights. But remember, we need new laws. We need new legislation to really protect our privacy rights. So I'd like you, we're on a roll right now, keep up the pressure on the political leaders. Let them know we need a new law that really protects all of our privacy rights. Anyway, thank you. I'd like to turn it over to Ken and the folks from H2O. Thank you for coming.
All right, I'm excited to be here. This is my very first meetup, which is crazy because we do meetups all the time. The H2O people do awesome meetups, and we only got some of them introduced, but we have about 6 or so of them here, and they're happy to answer your questions after our talk. So why is it my first meetup? It's actually, I've been at H2O for the better part of 7 or 8 weeks. So then the natural question is, Ken, where did you come from? And I came from a little analytics company called SAS. Right? So then the question is, why in the world why did you come from SAS and move into this open source space? And you know what? We started learning about how great the software was, and I started to take notice, right? That I can access any data source, and that I can run from almost any client, and I said, oh my gosh, this is great stuff. So I'm really excited to be here. I hope to get to meet most of you. I'm going to tell you a little bit about H2O before we dive all the way into to show you a live demo. Abney's going to come up here and do that. All right? But who's really new to H2O, like never touched it before? So most of you. That's really good. So I'm starting at the beginning. That's important. Now I saw some industries out there. I saw a couple insurance, obviously some telecom. Met a couple students earlier today. A couple in finance. Any industries that aren't represented yet? Oil and gas.
Manufacturing.
What was that?
Manufacturing.
Manufacturing.
Cannabis.
GIF. I'm sorry.
Weed.
There we go.
There we go.
There we get rolling. All right. All right. So what we level set here. H2O is a robust, tested, and supported platform for predictive analytics. We were founded in 2011. We've had a couple rewrites. The latest version 3, was done throughout most of 2015 and was released in late 2015. It is an open source in-memory prediction engine. We have about 50 plus people, almost all of which are core development folks and talking geeks like myself. That's basically what I did before here, and I guess I'm still a talking geek. We're headquartered in Mountain View, but we have sales and marketing support throughout the country. All right. Now, one of the reasons why I came to H2O, one of the things I thought was so cool is our advisory board are the rock stars of machine learning. So Trevor Hasty, Stephen Boyd, and Tip Sharani are all, like, they all hang out. Like, they come to the H2O offices, which is pretty awesome. So, like, Hasty was sitting in an office a couple weeks ago, and I actually like took a picture of him and put it out, put it on LinkedIn, and they said, "Oh my gosh, this is great!" Right? So a lot of the things they've been writing, we parallelize and have put into commercial grade, industrial grade predictive modeling. All right. So the platform. Basically, we are parallelized and distributed algorithms. What are those algorithms? GLM. So most of you probably know what GLM is. On top of it, we have a very robust package for penalized regression, or regularized regression on GLM, so lasso, elastic net, ridge regression. GBM, gradient boosting, deep learning, so that's a neural network implementation, low-rank models, PCA, k-means, and some other things as well. One of the cool things is it runs anywhere from almost anywhere, right? So anywhere you have a Java virtual machine, you can have H2O running. We can drive H2O from R, from Python, from our UI, which is called Flow. It scales really well, so you kind of don't need to change your code from learning about the data to actually productionalizing a model, right? And this is a very important thing. All of our models come with score code, right? So you learn something about your data, you want to operationalize the results. Every single model comes with a Java object. Yes?
I have 2 questions.
Sure, let's do it.
Maybe 3. One, is it actually, do you have an implementation running on AWS Lambda? Question number 2, are you supporting GPUs in the AWS environment? And number 3, are these algorithms anyway certified?
Are they certified?
All right, so you want to take is there any difference between Lambda and non-Lambda?
Yeah, there is.
All right.
So the quick answer is no, and what do you mean by certified?
Well, there needs to be, how do we know that these algorithms that you're providing are actually accurate?
You can compare them to any existing implementation.
So you don't have, let's say, in this, some type of certification, third-party certification stating that these algorithms are correct?
No, but we are open source, so you're welcome to look at the code.
Yeah, but that's not what,
The code is open
I don't
source.
want to be developing algorithms, I'm asking if they're certified in any way.
It shows up
Well, we
in the
can-
FDA clinical trials, you have to have, and SATs is always there.
Right. And we certainly don't claim to be a replacement for SAS's FDA certification sort of recommendation. But most of the tests are available, and we can take this offline, and if you want to benchmark for us, that'd be great. So, as I mentioned before, we have a bunch of supervised learning techniques, GLMs, naive Bayes, distributed random forest, gradient boosting, deep learning. In the unsupervised space, k-means, PCA, low-rank models. And then the last thing I'll talk about is the agnosticism, right? So regardless of where your data come from, we can read it. Regardless of how you want to drive H2O, that's an option. Meaning, if it's in Hadoop, if it's in Amazon, if it's a CSV, we read into H2O, it persists in memory, you estimate models, you compare models. So you notice I'm an economist, right? So I said estimate there instead of train, right? But you fit models, you can drive from Python, from R, from Flow. It's a single source of truth, right? So if you're in an organization and you have Python people and you have R people, or folks that don't write any code at all, they're using the same compute engine, right? And this is big for governance. So there's not like a bunch of packages that you would need to draw upon anymore. All right, and then finally, as I mentioned, every single model produces Java score code. And that's a great thing to operationalize your analytics. So with that, Avni's going to come up and do her thing. But I'm sure there are other questions in the audience. How can I get this software? Well, one way you can go get it is go to the H2O.ai website and download it right now. It is free to use and open source, so go for it. In fact, everybody leaves with a free copy today. All right, you want to swap out?
Yeah.
Well, I use the GPS. I don't think you'll ever come back in.
Stuck here.
Stuck. There we go. Here. What would you like? I'm gonna put some. That's a good break. You really
Base plan.
Does you have a Gorilla Glass on it? Or?
No, I didn't.
I had one of mine.
Oh, it's still
I don't think that's
Okay, so I'm going to first talk a little bit about the architecture of H2O and how it connects with R, and then we're going to go through a flow demo, which is H2O's web UI, and then we're going to do the same demo in R, so you can see how they correlate. It won't let me go there. So I already hit the next spot. Okay, so first step here is the R user will execute an R function call, and in this case that function call is h2o.import file. So this gives R the command to import the file and tells H2O the file path to the given file that you're trying to import. Next, the R function call is sent over the REST API, and this process is the same. It's universal for all the different platforms. So although we're talking about R in this case, the same thing would happen if you were calling or executing or initiating H2O from Python or going through Flow. Next, the argument gets carried over to the H2O instance, which is what this is, and it requests data from disk. So in this case, in the diagram that I'm showing you, this is a local instance, so this is specific to your computer. But if you were launching your instance from Hadoop, for example, you would be requesting data from HDFS. Okay. Next, the data is read into H2O through a parallel and distributed read. So this frame is created. The frame is then summarized, and the summary statistics are sent back to R as a REST API JSON response. So that's what's happening over there. And then the summary statistics result in a data frame being created. It's called an H2O frame, and that's what's sitting in R. So to be clear, that's similar to a data frame, the ones that you're used to, but it's actually just a pointer to an H2O frame, which is sitting back in the instance. So you've just created an object in R, and the frame is actually in the instance. Does anyone have any questions about that?
Yeah.
Yes.
How does the translation between an H2O frame and an R frame work?
Could you repeat the question, please?
Yeah.
The question was, how does the translation between an H2O frame and a data frame work?
So they're essentially the same thing from an API perspective. They all conform to the same APIs as the hardware.
Is the layout different? Is there any additional overhead if processing a lot of information?
So I would say no, because any computation that you actually do is happening in a Java instance. It has nothing to do with R.
Okay.
So R is just a pointer which said client API speaks over REST to the Java instance.
So there's no OTP mapping going on?
No, no.
Is the
H2O instance running in RAM, or are you?
Yes, yes,
running
yeah,
it?
yeah.
Okay.
So it runs in memory. Yes, absolutely.
Okay.
Since you got that up there, can you get to you obviously get to everything in H2O with your REST interface, correct?
Yes, that's correct.
Is that what is publicized? Because I have like an exotic visualization tool, and I'd like to talk to H2O with REST. Is that-
Yeah, so it definitely is. It is documented. Yeah.
There's an integration with Tableau. You have to do some work.
Right,
but you
yeah.
can easily use leverage the REST API.
Yeah, because I have a lot of different stuff, so and I'd also be curious to see how, what you got there.
Yeah, definitely.
Okay, great.
Anyone else?
Scalability, you said that it's scalable, and you're reading size files. How much kind of size are we talking about?
So in this example, this is just a local instance, so you can play around on your computer. So as much RAM as you have, that's going to be the limit. As mentioned, so the key is that we're distributed, so our real power is when you take that, put it on a bunch of, say, AWS servers, you try 40 gigs of RAM, and you spin up, say, 4 nodes that cluster together, right, and suddenly you're talking about 160 gigs of RAM to load up your data. So, you could also leverage, say, Hadoop, right, so we leverage Yarn typically, so you just submit a Hadoop mapper job, you specify how many nodes, each one of those nodes is a mapper in Hadoop, so Yarn will give you that 6 mappers, that's 6 nodes, however much memory you want, depending on how much resources you have in Yarn. And basically, to your heart's content. I will say, just a note that typically we suggest 3 to 4 times the amount of memory of your file size, and that's because when you're actually doing the model builds, we're going to need that memory to actually do temporary storage. That being said, the actual file, so if you take, and this depends completely on the data set, but we're columnar compressed, and we're very good. So you might ingest a 10 gigabyte file, and that might come down to 500 megabytes. So it really depends on the data set. You have to play around.
Well,
Our heuristic is 3 to 4 times.
I've got data set of terabytes of airplane data.
Yeah. If you have machines and the amount of memory, then yes. Wait, absolutely.
So my understanding is your boundary, your object boundary is the system memory.
Yeah.
How do you interoperate with things like RDMA technologies or memory mapped disks? What I'm really asking, if I have a flash disk that I'm memory mapped into the flat space, is there a way that I can direct your temporary storage or overflow of temporary storage into a flash disk?
Could you please repeat the question? We can't hear it back.
It was a long one, so I was going to repeat it. Is the flash, you're using it as storage though?
Yes, I use PCI Flash as a slower backing system.
Right, okay, understood. So right now we don't support anything like that, so when you actually load up H2O, we're going to be running in your actual RAM, so you won't be able to leverage that right now.
Okay.
So the question was, just to be succinct, can I leverage my flash storage, which acts just basically as normal storage, but is really fast? Anything else?
So is it possible to connect any of the traditional ERP systems or big data warehouse?
Sorry.
Is it possible to integrate with the existing data warehouse or an ERP?
I think we'll take it offline.
Okay.
There's a few, so we'll talk. Just come find me afterwards.
Sure.
Anything else? So we're going to move into the demo portion. Can everyone see in the back? Yeah. Okay, so this is Flow. This is our web UI, which provides you an interface to kind of point and click through your model build process. So we're going to get started. First, we're going to import our file. I'm drawing a file from S3 and it's airlines data. So the goal here is going to be to predict whether or not a flight is delayed based on historic airlines data.
The answer is true? Right.
So we're at the parse setup phase here. So as you see the source where the data is getting pulled from. You see the ID of the data frame that you're about to create. You see the parser, so we imported a CSV file and that's what it detected. These are the different types of files that we currently support. So Excel, SVN-Lite.
Third question? There's a question up there.
Sorry.
How big is that file that you brought across?
I'll show it to you. I think compressed size is 2 megabytes.
So for the sake demonstration on the local machines, it's small.
Yeah, we do saw it. Yes.
Do we have the option of adding arbitrary files into it if we put a scheme in place?
So right now, the answer is no, unless you're willing to implement that yourself in our code. And right now, most people just grab CSVs in terms of using this way of using H2O. If you have, say, ORC files, Avro files, Parquet files, any of those kind of big data, typical files, what we recommend right now, because we are working on our own native ingesters for those formats, is leveraging Spark, which has those, and we interop with Spark RDDs really simply. So that's kind of the way to go for that. And there's a lot of examples on our GitHub of how to do that. It's like SQL context, grab it as H2O frame.
Okay, thank you.
So the separators for this file are commas, but these are the different types of delineators that we have, so you can select a different one if your file type is different. You see that the option that says first row contains column names is automatically selected. So that's where it's drawing all of this information in our CSV file, the very first row are the headings. So this gives you a little bit of a summary of the data frame that you're about to create, a preview of it, and it auto-detects the type of variable that each variable it is that you've imported. So it's either a numeric or an enum most of the time. So a numeric is going to be a number, and an enum is short for enumerated variable, which is going to be a categorical, so it holds one of two values. So at this point, you can switch between numeric and enums or a different variable type. So I'm going to go through and switch a couple of the variables because I don't want things like year and month to be numeric. So we're going to just change year, month, day of the month, and flight number. As I mentioned earlier, we're predicting in this case whether or not a flight is delayed. So we have a binary classification problem because we're predicting one of two things. So for a binary classification problem, you have to make sure that the variable that you're predicting for is an enum. So we go through and we're predicting for this variable is departure delayed, and in this case it is correctly classified as an enum. So with that, we can parse that.
Is the flow, the interface, like we have to have an account or something, or is it just like a web API?
It comes up with every instance and you can save them.
Okay.
Okay, so we can view our frame. So you see the frame that's created, you get a little summary of the data set. We see that it's about 44,000 rows, 31 columns, and 2 megabytes in compressed size. You get an overview of the frame that you've created. At this point, you can also switch to enums or numerics. And at this point, you can also click on any of the given variables to take a look, get a couple visualizations around that variable. So I'll click on origin, and you'll get this visualization of the different origins of the flights in our data set. So next, we're going to split our data frame. We're just going to do a test chain split. So we're going to split it into 30 and 70%. This is a completely random split, so it's not taking the top 70% of your data and the bottom 30%. It's completely randomized, so every time you do this split, it'll be different. So the 70 I'm going to name train because it's the training data. It's what we're going to use to train our model. And the remaining 30% I'm going to call valid because that's what we're going to use to validate our model. Okay. So we're going to build a gradient boosting machine in this demo. So we're going to click on that. So you get a model ID if you want to name it anything different. different. I'm just going to leave it at its default. The training frame, we're going to select that train frame that we created a couple seconds ago. That's going to be the 70% of the original data frame. And the validation frame is going to be the remaining 30%. The response column is what we're predicting for, which in this case is the variable titled is departure delayed. We're going to select that. These are the columns that we want to use to predict for whether or not our flight is delayed. So these are actually ignore columns. So we're going to select all of them and then deselect the ones that we want to use to predict for our model. So we're going to deselect month, day of the month, day of the week, unique carrier, flight number, origin and destination, going down, we're going to build a gradient boosting machine with 50 trees. These are the default parameters, which we're going to leave the same for the purposes of this demo. Just one thing that I do want to do is turn on score each iteration, and what that does is give you statistics for every single tree that's built, rather than just at points where the model experiences significant changes. And with that, we are going to build our model.
Question.
Yes.
Yeah, I was just wondering, so I just saw there's an option for encode. So do you have the ability to like split it down into 3 sets or something? Maybe a test,
Yes.
a valid?
Yes.
Okay.
If you go back up here, see where it says add split?
Oh, okay, cool.
Yeah, you can add another one to be like a holdout set.
And when you do the cross-fold validation, when you specify parameters, you don't have to preemptively do the splitting.
Okay.
We'll do that for you.
But if you want to do a stratified sampling and you want certain group to go in one model, then you can specify an fold column.
Okay. Yeah, that was not highlighted, so not active, so I was wondering like.
So if you specify n fold and scroll down to the please. There's a fold column
Right here.
Yeah.
Oh, okay.
Did you have a question?
Yeah, just real quick, is it a good assumption that the data come in is as clean as it's going to get, right? There's no cleaning of the data in the tool, or you've already cleaned it at this point?
Yeah, in this case we cleaned it, and that's how we optimize flows. You should probably put in a clean data set.
So right now, in terms of our flow interface, the UI interface, we don't really have any munging capabilities. We have like some splitting, but generally it's pretty tame. So we recommend, and a lot of our users actually like this because they're already using R or Python to do their munging. So they'll actually use both, and they'll actually use Python or R to drive any munging feature generation. And when they start building the model, they'll hop over to the UI and see the build kind of in real time. You can see each iteration actually as it's going. So that's kind of where we're at right now, and we're trying to get our UI all set to do those things, but as you can tell.
Yes.
Now that the gentleman brought that up, what happens when you run into dirty data? What happens if you run into a text field and you're expecting an enum in there?
So the sparse is string. So we have type string. So if you want to convert it to an enum or a categorical, you can call as factor on that column. So what he meant was by using H2O's R or H2O's Python libraries, you can merge data, conversion, and all those functionalities are there in H2O R or H2O Python interfaces.
Yes, but in the ideal world, that's great. But in the real world, stuff goes through all the time. Will your algorithms just ignore the data, ignore that column, or will it go off into the weeds?
So that, in terms of training, say your NA columns, as an example, that'll depend on different algorithms, how they train. So for instance, our GLM will ignore that, our Forest won't ignore that. When you parse the file, when you actually do the parse setup, you specify what we do automatically detect it showed what we think the column is, and no matter what we encounter in that column, we're going to parse it as that thing. So at the time that you're actually running the parse. So there won't, by the time you're actually running a model build, there won't be you won't reach a field suddenly and it be some different thing, since you just wouldn't get to that step.
Yeah, because I've had packages, some commercial packages that run into it and have a field extra, just stop.
Okay. Exactly.
If you specify the column type by parsing as well, if you know it in advance, if you want this column to be read in as string, say, you can specify that by parsing.
Do you have any, so now that we're on NAs, right, do you have any techniques, like some regression techniques to fill empty values?
To impute, yeah.
Okay, I'm sorry, I did not hear it though.
We have the impute option, so you can impute by like mean or median.
Or by any
I mean,
number.
yeah.
Great.
Can we write a custom function? Like for example, if you want to interpolate using, if you want to interpolate the value somehow, I'm just saying, for example.
I'm sorry, could you repeat that?
Can we, if I want like a custom function by which we want to impute the values, can we like provide that?
So that's something we're kind of actively working on, because that's very hard to do. Say if you define your own user, like our function, and you do some crazy stuff, and for us to run that within our cluster, that's something we're actively working on. Right now we typically support kind of all the standard functions, so mean, standard deviation, things like that, like length, just kind of the basic primitives. So that's on the way. That's a huge priority for us.
Thanks.
Anything else?
Do you have any limitation on the number of columns or characters you can import it? Like we are running through an issue where we cannot import more than 150 columns. We got like crazy 200 in my existing. So,
No.
With 150 columns?
yeah, something
Oh
like
yeah,
that.
we'll definitely be fine.
No, I mean, do you have any limitation? I just pick up the number.
We don't have like a hard build limitation. I don't think.
10,000, after 10,000 it gets kind of.
Yeah,
So
yeah.
and actually H2O releases data column. So we do well when the data sets are long. When they are very wide, then H2 won't perform well.
So very wide, but for us, very wide is 10,000 above. So the 150 range is.
Yeah, 150 range would be
not-
totally fine.
If you have more than 10,000 columns,
Okay, so now we're going to view our model results. So you get a couple visualizations. I'm going to make this a little bit smaller so you can see the whole thing. So we get a scoring history where you kind of get, can people still see in the back? Yeah, okay. So you get a relationship between the number of trees that are being built and the declining log loss. So you could click along the curves. The blue curve represents the training data and the orange one represents the validation. You can click along on any individual tree and get a series of statistics like mean square error, log loss, and AUC for each of the given trees. AUC curves are also produced for both the training and validation data sets. So what we care about is the validation one. You can click along the criteria drop-down menu. So if you click on like max precision or like max accuracy, it'll select that threshold point and give you statistics such as the false positive rate, false negative rate, and a confusion matrix for that given threshold point. You can also select a series of threshold points in that, and you'll get a series of statistics as well as confusion matrices for each of the given threshold points that you select. This is nice too. You get a variable importance chart, which will show you which variables were most important in creating your model and which had the heaviest weightage. Gains and lift table. Go over. A photo is automatically generated. So this is the Java object that you would be using to productionalize the model that you've created in Flow. So you can easily download this and generate it pretty quickly. Let's go over hyper. So going back up, if you wanted to enable the hyperparameter search method, you would select these radio buttons on the side. So in this case, I'm going to enable the grid search for the number of trees and the max depth. And you see the semicolons come up, so I'm going to put in like 25 trees and a max depth of 2. So now it's going to create 4 different models with the 4 different combinations of trees and max depth. Does anyone have any questions? No? Yes?
How's the variable importance? How does that work?
The question is, how does variable importance work?
So it's calculated differently for every algorithm. I'm actually not sure how to do it for GVM, and I could look it up. It's pretty, do you know maybe?
Yes, the way it works is to decide on the split what variable is being used and which one is minimizing the mean square error. So that is what, and then it will be added across all the trees to calculate the importance, relative importance of each variable. So for GVM, it's the normal Friedman implementation that we have. That is how it is implemented.
Can you look at interaction effects? Interaction effects between the variables?
No, this is just the simple relative influence.
And we actually recently added interactions as a separate library call from our client APIs. So I don't know who asked the question, so I'm kind of looking. So you can run that to generate those interactions between different versions.
So you see that the 4 different models are built. You can click on each one and see how the different parameter combinations change your model results. Yes?
Once you've chosen and run your algorithm, if you want to do a different algorithm, do you have to reload the data, or can you use the data that's already loaded?
You can reload you can use the same data. So if, for example, I wanted to build a GLM model, the training frame is still available and you can just select it here.
Quick question on that.
Yes.
So you choose the training frame again. Do you have to go through the same variable selection again though for the new model?
Yes.
There's no way currently to say if we select variables, how to build new models.
What you could do is code it in. So
Yeah, through the actual programmatical APIs, it's very trivial since it'll be just like a string that you define or a vector you define, and you can reuse that vector and say, hey, this is like my X is
this listed there.
Like a column vector of these predictors, and I can just keep passing that into the model. But from the UI, unfortunately,
for sure,
but in Flow, like if you wanted to, you could build your model this way.
Okay.
Yeah. Anyone else? A couple other things to go over. So you can save these flows. You can title them if you want. So airlines flow, and then you click on flow and save flow. So this is save the notebook, and what this is saving is these CoffeeScript cells. So if you reopen it, you can run each of these cells and it'll build the model again, so you don't have to go through the selection process and all of that. A thing to note though is when you save this, it will get deleted once you close down your instance. So once you shut down your H2O instance, this will be lost. The way around that is to download the flow. Because if you download it, it'll save to your downloads folder, and if you want to reopen it later, you just open that. Okay, I think that's all for flow. So now let's do it in R. Okay, so this is our studio, and we're going to build the same model. We're going to build a GLM model now, and we're going to do it in R. So first we're going to import the H2O library. H2O library.
Could you zoom in by chance?
I'm sorry?
Could you zoom in, make it bigger?
Oh, yeah, sure. Is that good?
Sure.
One more? Okay. Yeah?
Yeah, that's good.
Okay. We're going to initiate our instance of H2O. You see that it started. We are going to set the path to our data set. This is the same data set in S3. And then using H2O.import file, which I showed you guys earlier, we are going to import our file. We can get the dimensions of the data frame. You see again the 44,000 columns or rows and 30 columns. And we can get a summary of this data frame by running a summary on it. So yeah, it'll give you a general overview for each column, including the min, the mean, the max, and the number of NAs for each given column. In R, we can do some visualizations that weren't available in Flow. So we're going to create a histogram here that's going to show you the relationship between the year and the frequency of a given flight. We're also going to build a scatter plot, which shows you, I'm sorry, it's so zoomed in, but it shows you relationship between the distance and the air time. Next, we're going to use H2O's group by function, which is an easy way to kind of look at relationships between two given variables very quickly. So in this case, we're going to look at the relationship between the month and the number of flights that were canceled. We're saving it as a data frame and then displaying the frame. So get that. As you guys remember from Flow, we went through and changed a bunch of variable types from numerics to enums, and that's what we're doing here with as.factor. So we're changing year, month, day of the week, and canceled to enums. So this is just an example of some feature engineering that you can do in R that we couldn't have done in Flow. I'm creating two parameters, arrival time and departure time, and then creating a new feature called travel time by subtracting the departure time from the arrival time. So that's just an example of some simple feature engineering. Also in Flow, we did our test train split. We created a 70-30 split. Here I'm going to do an 80-20. So data.train is going to be the 80%, again a random split, and data.test is going to be the remaining 20%. So here we're going to set our predictor and response variables. So our response variable is departure delayed, and we're using these variables to predict for whether or not the departure is going to be delayed. And with that, we can build our GLM model. Y is going to be the response column for response variable, which in this case is departure delayed. X is going to be this list of variables that we're using to determine whether or not the departure is delayed. The training frame we're setting as that 80% of the split that we just did, and the validation frame is the remaining 20%. For a GLM, you want to classify the family, and we're classifying it as a binomial because, again, this is a binomial classification problem. So predicting one of two things. And with that, building our model. I just gave it a model ID called GLM model. You can get a summary of the model that you've built in R. Just by running the summary function, and you get a series of statistics for both the training and validation data sets. So here you see it for training, you get the confusion matrix. Same for validation, down here, that's confusion matrix. Going back to Flow, if we hit get models, you see that GLM model, the one we just built in R, is readily available in Flow. Click on that and get the same visualization. These are the ones that we have for GLM, the scoring history, and your AUC curves. And this. So this is specific to GLM. it'll give you the standardized coefficient magnitudes. So the blue lines represent negative correlation and the orange ones represent positive correlation. So that variable is positively correlated with whether or not the flight is delayed. And lastly, again,
Do you do Bronco colors on purpose?
Yep. And then again, the Pojo is created, so you can take a look at it, download it, and use it for production. That's all I had. Does anyone have any questions?
Sorry, I think I missed a step. How do you go from your R code to the H2O flow?
So by just going to this address, localhost 54321, that's the default address that you would use to get to flow from a local instance. You can specify it if you were doing it from Hadoop or H2O.
Do you find when most people operationalize it, do they export the model? Was it JavaScore? Is that what it's called? Or is that PMML? How do you find most people operationalize?
Right. So it's not PMML. So it's just a plain old Java object. It has a single jar dependency, which you also grab. So if you go to preview Pojo, oh, you're on it. So the first, it's right there. So the first two lines, you curl the H2O gen model. That's that jar dependency, and then the second curl call is for this actual file that you're previewing. So you package that into whatever it is that you want. We also have. So this Pojo right here has a score 0 method, which if you want to fumble around with, you're more than welcome to. But we have a wrapper API, an easy scoring wrapper API that's on our website, which makes it really simple to just pass the values that you want to. So basically one row of data to score on, so whatever the model is.
Oh, nice. Okay.
Any functionality for like XFX models?
Mix effects model?
Yeah, for like nested data.
Not right now. No.
If you were using HDFS, so does this algorithm, does it to take care of running the algorithm across the cluster?
Yes, it does. So when you run it on HDFS, so you go to your edge node, right? So whatever that happens to be, you just run Hadoop jar H2O driver.jar, which you also download. It's all on the website. That will actually call it to Yarn. Say Yarn, I want this many nodes. Yarn will give us whatever it is that we want, and the rest taken care of for you.
Yeah, it's a pretty easy setup. You just select your distribution. And with these commands, you specify the number of nodes and the number, or the, space allocation that you want to give to it. And yeah.
There's another question for you gentlemen, when you just have a gigantic data volume. So what we've seen some people do that have just such ridiculous amounts of data that they can't put it in memory, is they'll train on as much data as they can, and they'll actually, if they're using, and they are, Hadoop and Hive on top of that, then they'll actually use a Hive UDF, so user-defined Hive function. They'll embed the Pojo that this outputs, and then you can score directly on the data from Hive, right? So you just call select all my defined function, and you can score on billions and billions of rows. It's pretty wicked fast. And then the instructions for that all on our GitHub website. There's a lot of examples there.
A small question. How would you compare this with GraphLab?
With GraphLab.
GraphLab.
I really can't make any comment on that for me personally. Yeah.
Okay. Okay.
Anything else? Okay.
Awesome.
We'll be around, so if anyone wants to call,
If anybody wants to come chat, I'll find. Thanks for coming.
Thank you.